Welcome everyone to my talk, Are All Programming Languages in English? Before we start, let me introduce myself super briefly, I promise. I am Michele. I work as a staff developer experience engineer at Nearform. I'm a Google developer expert and a Microsoft MVP, and I come from Italy. Let me ask you, how many of you put pineapple on pizza? Let's be honest here. Okay, goodbye. Has been good. No blame. Everyone has their own taste, I guess. Also, yes, I'm Italian, but I'm also a huge programming languages nerd. I've been spending a lot of my career playing around with different programming languages, failing every single time, and eventually I found myself writing a lot of JavaScript lately. In fact, I work at Nearform. We are a professional services company, and we are specialized in JavaScript, TypeScript, Node.js development. We maintain a large portion of the Node.js runtime. We are responsible for maintaining like 8% of the global NPM packages out there, which gets downloaded like 1 billion times per month, which is crazy. And we are hiring full remote everywhere. So if you're interested, I'll be there. It's pretty important for me to highlight that I'm a JavaScript developer myself, because the idea for this talk started with a big rant in the JavaScript community. How many of you are JavaScript developers? Good. No worries for the ones that are not JavaScript developers. I'll be explaining you why I had to rant so bad about something that led me to create this talk. So you have to know that in JavaScript, we had different iterations over enhancements for the programming language itself. We had like ES, which stands for ECMAScript, which is the formal name for JavaScript. We had like ES3, which is a very old JavaScript version. Then ES5, which is a newer JavaScript version. And now we have ES6, ES Next, etc. We are not good at counting in JavaScript, as you may guess. But yeah, so ES6 has been like something that changed forever the way we write code in JavaScript. And if you're not a JavaScript developer, let me show you this. So it basically introduced many functional-like features such as filter. So if we have an array of numbers and we want to filter out all the odd numbers, leaving us just the even one, when we had like only ES5, we had to loop over the original array, select those who are even, push them to a new array, and then we had a new array. But with ES6, we have the filter method, which kind of makes sense, as you can see, right? You basically pass a callback function, and you say, OK, I will filter out just those just those numbers that are even. Makes sense. Filter, even, right? We also have the reduce method. Reduce method, we basically reduce something to a unique value. So we have like an array of numbers. We want a sum of all the numbers inside of the array. With ES6, we had to loop over all the numbers and sum everything together to a single variable, and we have a single variable containing the sum. But with ES6, we have reduce, which again makes sense. Reduce as a keyword is telling me we reduce a collection of stuff into a single value. Makes sense, right? Then we introduce the map method. Map method, for example, let's say we want to multiply every single number inside of an array. We used to loop over every single number and multiply it two times. And that's how we used to do that in ES5. But in ES6, we have map. But filter made sense to me. Reduce made sense to me. What about map? Why should I call this method map, right? Well, thankfully enough, I've been coding in Haskell for quite a long time before jumping straight into JavaScript. How many of you are coding in Haskell? Wow, that's perfect. Awesome. Just one person. That's incredible. No surprising, but still incredible. So yes, I need to introduce the biggest monstrosity that humankind ever introduced to programming, which is not Haskell itself, but category theory. And please, bear with me for like 2 minutes straight so I can start my rant against the map keyword, because this is leading us to a total new universe of programming languages that are not in English. Spoiler alert. So basically, I've been coding in Haskell for a bit. So when I said, like, OK, map method in JavaScript kind of makes sense to me, because we had that in Haskell. It's just the same. But why is it called map? So we find out that in mathematics, specifically in category theory, a functor is a mapping between categories. What the hell? Why should I know that to code in JavaScript? Let's go further. Category theory, so again, can be helpful in understanding Haskell's type system. There exists a Haskell category of which the objects are Haskell types, and the morphism from type A to B are Haskell functions of type A to B. What the hell again? Why do I need that information to code something using the map method, right? Well, I will be very shallow, so my friend coding in Haskell, I'm sorry, I'll be super shallow now. But basically, we can picture a map as a collection of arrows that go from elements of one set to elements from another set. So we have like John, which is part of one set, which is linked to eggs, which is part of another set. And so basically, John's favorite breakfast is egg. Mary's and Sam's favorite breakfast is coffee. And if you translate that into JavaScript, the mapping operation is nothing more than the set of morphisms from one category to another. And that's, again, super shallow, but that now makes sense. But why should I learn that in order to use the map method in JavaScript? Because you have to know that if you've been coding in JavaScript for quite a long time, using map, filter, reduce has been quite a breakthrough in the JavaScript community. And it wasn't easy for people to grasp these concepts. And people like me coming from a functional programming background, it was easier for us. But I guess it's still pretty hard to explain, right? The reasoning behind all these new features. And especially if you go down the rabbit hole of functional programming, you start looking at jargon and stuff and whatever. And I truly believe that keywords and jargon in programming can be a huge problem. How many of you are native English speakers here? No one? Great. Awesome. So I started ranting a lot because why do I need to learn a new language, which is English in my case, for understanding, this method is supposed to do that stuff because it's named like that, like map, etc. So I started wondering myself, is there a programming language that doesn't use any English-based keyword at all? And yeah, let's go down the rabbit hole together, and we need to start from a brief history of programming languages itself. So I'm sorry, I need to get you bored for the following 10 minutes to explain how programming languages started. And when we think of programming languages, we have to think that the first high-level programming language out there, it's not really high-level those days, but at the time it was, has been invented by Konrad Zuse in 1942, 1945 as his PhD thesis, because he found out that basically programs were too complex to be coded without high-level languages. And if you think of high-level programming languages, plain calcul, which is the programming languages that he invented, is not the first thing that comes to your mind, right? This doesn't look like a high-level programming language. But still, if you go deep into the programming language itself, you can spot a couple of English keywords, such as and. And that's like the only example of plain calcul I found online, but I read an interesting paper that states all the keywords contained, and it contains English keywords. So we can say that the first high-level programming language ever invented contained English keywords. So that's a starting point. Then, if we wanted to use programming languages the way we use them today, we have to go to 1955, where Grace Hopper led the efforts for creating the first programming language expressed using English-like statements. And this programming language is Flowmatic. And this is how it looks like. It's terrible, right? But it was a breakthrough at the time. And if you're thinking, wow, yeah, a lot of English keywords, it kind of look like I'm writing in English. And it reminds me of another big monstrosity out there, which is COBOL, of course. So yeah, 1957, COBOL was invented as Common Business-Oriented Language at IBM, and it maintained a lot of the syntax of Flowmatic, and it's quite similar, if you ask me. And still, as you can see, it's just like writing English statements. That was incredibly innovative at the time. So now we make jokes about COBOL, but it serves his purpose for quite a long time. Almost in the same year, IBM created a formula translation program language as known as Fortran. And Fortran, again, it's quite different from COBOL, but still maintains English keywords for expressing algorithms, data structures, whatever we need, using plain English language. 1 year later, and this is pretty important for people like me that used to code functional languages, John McCarthy created Lisp, so in 1958. And again, this is a very funny language if you ask me, but still uses English keywords. So these languages have been so much influential that all the languages coming after has been influenced by the one we are looking today. That's why we are looking into that. And other important languages are like ALGOL. So algorithmical language, born in 1958, has been so influential. And let me tell you this, 3 Turing Awards awarded people worked on future iteration of this language. These people are Dijkstra, Wirth, and Noor. They all won a Turing Award. They were all incredibly talented engineers working on this language. So you can only imagine how influential ALGOL with his English keyword has been for the programming language development. Of course, we also had other important programming languages born in these years, especially before the 1970s, like APL, which stands for A Programming Language. How beautiful is that, right? That's clear, super clear. We also had Simula, the first object-oriented programming language ever invented in 1962. CPL, 1963. Then BASIC, oh my God, BASIC, 1964. And then B. I mean, quite similar to C, of course. But still, every language maintain almost every language maintain English keywords to be written and expressed. So again, what makes these languages we just so important? Well, as I said, every single language that we are using today, it's coming from one of those languages we just listed. There are others. I didn't want to bore you for such a long time, so I cut and I decided to show you just a couple of the more important. But for example, taking CPL programming language and making it together with B, we obtained the C programming language. And the C programming language has been incredibly influential. We can't deny this. So in 1972, the C programming language was born. 1985, C++ was born. Then Java, and I'm sorry, yes, we have Java. Then C#, which is kind of better. I like it more, but that's a personal opinion. And Lisp influenced the way we program today in an incredible way, and we will never acknowledge that enough. So Lisp influenced ML, which stands for meta language, which is the language that basically paved the ground for OCaml, Haskell, Idris, and other programming languages that nowadays are influencing a lot the way we write program. For example, how many of you are writing in Rust? Cool. 1.5 people, I see. So Rust has been written in OCaml and maintains a lot of the stuff that OCaml has to offer. And Haskell, for example, has been incredibly influential in Java, C#, C++, if you think of generics, for example. So it's really important to acknowledge that Lisp, which paved the ground for Haskell, has been incredibly influential for the way we program today. But apart from ML, we got Scheme, Camel, Racket, Clojure, so other Lisp dialects except for Camel. ALGOL has been influential in another way. So Simula, the first object-oriented programming language out there, has been incredibly influenced by ALGOL. Then we got Pascal and Delphi, which are still used today. So it's really pretty important to acknowledge that. But you now may be thinking, okay, all right, all the programming languages that we just saw were born in the US, right? So it makes sense that they wanted to maintain English keywords. Well, this is not totally true. In fact, I'm European, and as an European, I used to think that everything was born in the US, because of course they're really good at making programs, of course. But when you dig deep into programming languages, you will see that, for example, object-oriented programming was invented in Norway in 1962 by Ole Johan Dahl and Christian Nygaard, and they invented object-oriented programming. Pascal, incredibly influential programming language out there, was invented by Nicholas Wirth in 1917, circa in Switzerland. And Python, how many of you are writing in Python? Good, you're writing in every single language. My God, lucky you. No, I'm kidding. Was invented in the Netherlands. So you're using a Netherlands-based programming language. Or if you think of Ruby, 1995, just like me, in Japan. And in 2003, Elixir has been invented in Brazil by José Valim. So if you go and see in the online historical encyclopedia of programming languages, we see that we have around 8,900 known programming languages, and 2,500 of them were born in the US, of course. 600 of them were born in the UK, 160 in Canada, and 75 in Australia, and they all have in common just one thing: mother language. So around 35% of all the programming languages we know today has been invented and developed in English-based in English-speaking countries. But the original question was, is there any programming language that doesn't use English keywords? Well, let me go a bit further than that. We have programming language that doesn't use any keyword at all, and I love this. So let's dig into symbolic programming languages. We actually already saw something about symbolic programming when we were discussing, for example, APL, which stands for a programming language. And yeah, this is an APL an hello world in APL. Yeah, no, too easy. Let's go with another program. Okay, list all the prime numbers from 1 to R. This is how you used to do that in APL. And if you're wondering, did people really code using APL? Yes, they were using that a lot because it allows you to write very complex statements in a very tiny space, which if you're using like physical devices for storing data, this is a good way for compressing data, basically. But the problem was that you had to use Unicode keyboards. And they were very expensive because few people use them compared to regular keyboards. For that reason, other programming languages such as Key evolved. And as you can see, this is basically the exact same program. Let me show you again, APL, Key. This is the exact same program, but uses regular characters, basically. Programming languages based on APL evolved even more, and now we have J. Oh, I love names for these programming languages. These are dope. That's an example of a quicksort algorithm using J. So you can express any kind of algorithm, any kind of computation, any kind of data structure using just symbols and no keywords at all. But we already discussed functional programming. So if we think of lambda calculus by itself, it's not a real programming language. I mean, it's a mathematical computational model. But if you feed a scheme compiler with that code, it will work just fine. So you can use it in a way that you basically create programs using only functions. And this is the foundation of functional programming, basically. We have other programming languages such as Prolog, which I love, logical programming language, so a totally unknown paradigm out there, which basically uses keywords, but you can decide not to use them. So you can express, for example, a quicksort algorithm without using any keyword at all. You just don't need them. And this is closer to other programming languages we are using today, such as Erlang, etc., of course. Apart from that, symbolic programming languages seems like something people don't use yet a lot, but that's not quite true. People are using symbolic programming languages quite a lot. I just don't know where, but they're pretty used somehow. But talking about stuff that people use is just to have fun, we have to introduce esoteric programming languages. I know that people knows where I'm going with this. Of course, I'm going to brainfuck. So brainfuck, it's a programming language that only uses 8 characters to work. So you basically have these 8 characters. So greater than sign, less than, plus, minus, open square bracket, close square bracket, comma, and a period. And every one of those characters is basically doing something on a tape, which we can think of as an array of a fixed length, where every single cell inside of the array starts from 0, so contains basically an integer starting from 0. Let me show you how it works. I won't go deep into the explanation you're seeing here. So let's say we use the command plus, we increment the counter inside the cell we are in. Then we use the greater than sign and we move on the right in that case. So we are now in cell number 1, starting from 0, of course. Then we use the increment sign. We use it again, so we are now have 1 in the 0 cell and 2 in the first one. So we go back, so less than sign, we go back to cell number 0, and we decrement, so we go back to 0. Then I forgot to move, sorry, okay. We move on cell number 1, we use the period command, and we basically output to the standard output whatever we have inside that cell. You may be thinking, okay, but I just want a hello world program, right? How do I do that if we only have integers? Well, we can use ASCII. So for example, capital A is 65. So if we have like 65 instead of a cell, it basically means A. If we have, I don't know, lowercase a, it's 97, for example. So you can use the entire ASCII table to represent strings, for example, inside this tape. So, for example, this is a program that prints a to the standard output. So you basically increment the first cell 97 times, and you get capital A. This is crazy. There is there is a best way for doing that. So I'll show you. So let's go on cell number 1. We increment by 1, increment by 2, 3, 4, 5. OK. We now have 5 here. We start a loop. Remember this. We move to cell number 1, and we increment 19 times. This is not very optimized yet, but it's just for the sake of showing brainfuck, which is something I never expected to say out loud. But OK, so we increment 19 times. Now we go back to cell number 0, we decrement, and we close the loop. So the loop will exit whenever inside this cell we have a value of 0. Let me show you how it works. So we basically just created this program. Go to cell number 1, increment 19 times, go back to cell number 0, decrement, and close the loop. So it means it basically works like that. We increment, sorry, yeah. This clicker is working the other way around. That's crazy. We basically continue going from cell number 0 to cell number 1, and while we are decrementing, while we don't have 0 on cell number 0, we will be incrementing cell number 1, so that at a certain point we will end up in that situation. We exit the loop, we have 0 on the cell number 0 and 95 in cell number 1, and we will just increment 2 more times, command period, and we have capital A. And if you optimize this even more, you basically create an hello world program in brainfuck. So how beautiful is that? Round of applause for brainfuck, please. You're applauding to brainfuck. Shame. OK, if you're interested in learning more about how brainfuck works, I created an article to write a brainfuck compiler in JavaScript. It's super fun. It helps you a lot understanding how it works. But OK, let's move away from this beautiful programming language for a moment. And let me show you other esoteric programming languages. We have Shun. This is an hello world in Shun. I have no idea how it works, and I couldn't find any compiler online for that. I only found some documentation on GitHub. We have Elang. We have Integ, which only uses ASCII values. And get ready, because this is totally crazy. We have Bifungi, which basically it's a b-dimensional programming language. So every time you encounter a V, it means, OK, go read vertically, not horizontally anymore. Why? And this is, I guess, the number game. So you basically have like, it creates a random number between 1 and 3, so it's pretty easy. But you have to guess the number, and it basically loops over all the results until you find the right one. And this is totally crazy. You might be wondering, where do I typically use these programming languages, right? They are not really meant for production usage. I don't know if you're brave enough, but I don't know if you're familiar with the concept of code golf. Code golf, it's a nice discipline where you basically have a problem, and you want to solve that problem using the less characters possible. So whatever programming language you use, you typically don't choose Java for that, but you have to use as fewer chapters as you can. So let me give you an example. We have this one, sort numbers in a rugged list. We have an input, and this is the expected output. So as you can see, we maintain the array structure, but the integers inside the arrays are sorted, right? You can solve this with Jelly with just 3 characters. You can solve that with Retina in 5 characters, Vixal in I don't know how many. And for comparison, this is JavaScript. So JavaScript, it's a pretty compact programming language, but still can't compete with the esoteric programming languages. So this is where you typically want to use one of those crazy programming languages. And believe me when I say there are a lot of those out there. But if esoteric programming languages are not your thing, and I can totally understand this, let me say that there is a good alternative to that, non-textual programming languages. Who said that you have to write text to write programs, right? So let me give you an example. We have Pete. If you feed the compiler with that image, it will print Pete as an output. And of course, it's dedicated to Pete Mondrian. This is a canvas from Pete Mondrian. And this is an hello world using Pete. So you have to choose the colors, you have to choose the size, you have to choose the design of the canvas, and depending on how you create your images, it will output something very different. And don't ask me how to debug that, but okay. I wouldn't consider this textual because we also have white space. Yes. Okay, I'm not messing with you. This is actually a programming language. And you basically use just tabs and spaces to compute your stuff. And this is like, say hello, it's completely ignored, because why caring about stuff? But just tabs and spaces. And then we have my favorite programming language of all time, which is called, get ready for this, Velato. So if you have like a keyboard, you have to play this score using a MIDI interface, and the compiler will listen to the music, will listen to the MIDI output, and will basically output a beautiful hello word out of this score. So it's a musical programming language. I don't know, but I love this a lot. And okay, now we are almost there. We started the talk asking ourselves, is there any programming language that doesn't use English keywords at all? Of course. So let me introduce non-English based programming languages. Let's start with Teuton, which is like a German Python, because why not? And yes, it's, it's basically Python, but you use German keywords, which, all right, why not? We also have Lino, which it's basically almost like Algol, but in French. So you say like bonjour le monde, début, and etc. I can't speak French very well. Is there any Polish in this room? Someone speaking Polish? No one? Okay. Oh, great. I need your help. How do I pronounce this? The text you mean? Yeah, System Automatycznego. Thank you, thank you. So this is basically a Polish Fortran. And it was pretty used in Poland, actually. So it's has been in the past a quite popular programming language that was used for teaching Fortran to Polish students. We also have Rapira, which uses Cyrillics, of course. We have Imawari, if you are into Japanese. And I have no idea where it takes the inspiration from, but I certainly know where Kalbon takes its inspiration from, because this is the Arabic Lisp. So if you write Arab and you like Lisp, that's a match made in heaven. And then we have APL, Easy Programming Language, which is basically C with Chinese keywords. And again, we might think, I will never use that, of course, but you can teach students how to reason in terms of computation using something like APL. So that's the reason why we have these languages. And I want to self-promote a bit. Is there any Italian in the room? I'm the only one. So everyone against me with pineapple on pizza. Okay, all right. I created the Cadrega Lisp, which is a programming language. It's basically a Lisp that uses my local dialect, and my grandma helped me creating this programming language because I can't speak my own local dialect. And I basically wrote this. It's a Lisp. You can test it out, but you can also fork it. It's written in Haskell, so if you want to go understanding how to create your own programming language, you can fork it and just change the keywords. It will work just fine, hopefully. Otherwise, let's hope in a bug. So, are all programming languages in English? I would say almost, meaning the programming languages we are using today in production, of course, are based on English, except for, let's say, a couple of rare exceptions, such as Lisp written in a certain way, Prolog if you do like a strange way of doing machine learning, etc. But of course not. We have a lot of programming languages that are meant for teaching people in their own native language how to program and how to write algorithms, data structures, etc. So I'm not advocating for any of those, but I guess it's really, really fun to test out some esoteric programming languages, non-textual programming languages, and I hope you could find it interesting too. That was all for me, and thank you so much for being here. It's been an honor.